please do press the hike button so that it gets maximum reach. Okay, and if you want to follow me on Insta, this is my Insta ID: OJHALAKHYAJIT123. That's my Insta ID. Okay, so you can follow me on Insta. Now you see, what is the question here? Three rigid spheres are connected by light flexible rods with relative masses m1, m2, m3, and these are in the ratio 1:2:1. Describe all the normal modes of system and the normal frequencies. So here we're gonna consider the three spheres. Let me write here. Just give me a second. Okay, what we're gonna write here? Just give me a second. So we're gonna write here. Let us consider three rigid spheres are connected by light flexible rods with relative masses m1, m2, m3. Okay, so suppose these are the spheres. Here you see these are the spheres. Okay, these are the three spheres. Okay, as the rods are flexible, we can treat as spring. Okay, we can treat as spring. So its mass is m1 and its mass is m2, its mass is m3. As they are in the ratio 1:2:1, so we can consider that m1 is equal to m, m2 is equal to twice m, and m3 is equal to again m. Because if you find the ratio of m twice m and m, then you are gonna have 1:2:1, right? Hope you have understood this. Okay, so we have considered that way, right? And let me consider a coordinate system like this. Okay, this is the coordinate system. This is x, this is y. Let me consider that way. So here you see this position. Let me just give me a second. Let me consider this is the x-axis. This is the x-axis. They are on the x-axis. Let me consider that. This is the x-axis, and this is the origin, suppose. And here, this position, this initial position is your x0, 1. Sorry, x0, 1, and this position is x2, x0, 2. Sorry, and this position is x0, 3. Right? Let me consider it. Okay. So we have considered x0, 1, x0, 2, and x0, 3 be the positions of m1, m2, and m3 respectively. When the time t is equal to 0. Okay, I have considered that way. Now let me go to next slide. Here is the new slide, and this is at the position x0, 1, x0, 2. This is x0, 3. Okay, I have considered it that way. For simplicity, let me take this 2m is equal to, suppose, capital M. Let me consider this 2 small m. Let me instead of writing twice m, let me write capital M for the time being. Okay, then at the end we're gonna put 2m instead of m. Now you see, that means, let me go back to the previous slide. Here let me consider this is, suppose, capital M. Okay, consider that way. Right, now you see, at any instant any instant t, the positions of m1, m2 and m3 be respectively so at any position, suppose at any instant t, their positions becomes their position changed, and the new positions are suppose x1, x2 and x3. Let me consider that way. Okay, this is m, capital M and small m. Okay, right. And the displacement from their original position, let me consider eta 1. Okay, and displacement of this capital M sphere, its displacement is suppose eta 2, and its displacement is suppose eta 3. Let me consider it. Okay, so here eta 1 is equal to displacement of this first sphere. That means, you see, this is the x-axis and this is the first sphere of mass m, and initially when t is equal to 0 it was at x0 1. Okay, and it displaced through displacement eta 1, and its new position is suppose x1 when at any instant t, when the time is t. So then this eta 1 will be given by this x1 minus this x0 1, right? That eta 1 will be given by x1 minus x0 1, right? Hope you have understood this. So we can write x1 minus x0 1. Similarly, eta 2 is equal to x2 minus x0 2, and eta 3, this is not an eta, okay, this is eta. x3 is x0 minus x0 3. Okay, we have considered it. Now you see, we're gonna consider we're gonna find the potential energy of this system. Okay, so now you see, potential energy, here we're gonna need a spring constant. Let me consider that be k. Okay, here is spring force constant, you can consider that way. So here first we're gonna consider this coupled system. There are three spheres like this, right? Three spheres this way. We're gonna first consider this two system of these two, and then we're gonna consider system of these two, right? Then and potential energy of such system, it will be better if you remember this step. Okay, and if the displacement of this is eta 2, okay, here actually we are applying Hooke's law, that is potential energy is equal to, if suppose you have a spring and on this side it is rigid and you have a mass m, and if it displaces, if the spring is pulled and it is displaced through a displacement x, then potential energy is given by half kx square, right? So if we apply that formula, okay, but now instead of one object, here we are going to consider this system of two particles, these two spheres. In that case, you have to subtract these two displacement. Okay, so here half k eta 2 minus eta 1 whole square, then we're going to consider system of these two, that is half k eta 3 minus eta 2 whole square, that way. And kinetic energy we know half mv square. Here half mass of the first one is small m, so its velocity, if the displacement is eta 1, then velocity is its time derivative, right? If the displacement is x, then velocity is given by dx by dt, right? Here displacement is eta1, so d eta1 by dt. So instead of writing this way, I have written here eta1 dot. Similarly, for the second object, we can write m eta2 dot. So here the mass is I am taking capital M, and for the third sphere, we're gonna take half m eta3 dot, right? So here you see from these two we can take half m common. Sorry, I forgot to write the square. Actually velocity square, half mv square, right? Velocity square. So we can take half m common from these two terms, and on taking half m common, if we rewrite this relation, this expression in this way, we can write this way: eta1 dot square plus eta2 dot square plus half capital M it's supposed to be eta3, this is supposed to be eta2 dot square, right? Hope you have understood this. So we have got these things. So now pause the video and note this. Now I'm gonna copy these two, and I'm gonna go to, I'm gonna take a new slide. Okay, first pause the video and note all these things. So let me go to a new slide. So here these are the two steps that we have got: potential and kinetic energy. And from here we're gonna obtain two matrices. Now we can write this in matrix form. Let me show you one equation. It will be better if you remember the matrices. Okay, so now you see, as I have already shown you that this one this one was nothing but like this. Okay, m eta1 square plus half m capital M eta2 dot square plus half small m eta3 dot square, right? We can write this in this way. Here you see m 0 0 0 capital M. So write all the three masses diagonally in a matrix. In a matrix. Okay, this way, and half eta1 dot square, half eta2 dot square, half eta3 dot square. Okay, so we can write this part as the product of these two matrices, right? If you multiply this again, row and column like this, hope you know that matrix multiplication. So then again you're gonna get this. So here this matrix will be taken as capital, let me make it bold. This is obtained from kinetic energy. This matrix only, we are not going to take this part, only this part. Okay, and similarly, if you simplify this equation, then you're gonna get another matrix, that is, let me use here bold V. Okay, and remember that matrix will be of this form. So it is very easy to remember, and here you see k, then minus k, 0, then minus k, twice k, then again minus k, again 0, minus k, k. Just very easy to remember. First put those four minus k's. Okay, then here put twice k, and here plus k, plus k. Remember that way. Okay, so just for the time being, remember this way. Now you see, let me copy these two matrices and let me go to a new slide. Okay, here you see. So now from these two we're gonna get a circular equation. that is V minus omega square. Omega is the frequency here, omega square here, this T. So we're gonna take this determinant. Okay, so now you see, if you multiply omega square with this T, then here you will get omega square, here you will get omega square, here also you will get omega square, and remaining terms are 0, right? Hope you have understood that. Then if you subtract it from V, then you're gonna get this, let me show you. Then you're gonna get this K minus omega square M minus K 0, then minus K twice K minus omega square capital M minus K, then 0 minus K minus omega square small m. So we're going to evaluate this, this is equal to 0. Okay, this is called circular equation. And from this, if you use determinant, right, hope you know how to obtain this, how to simplify this, then you will get now evaluation of this. Gonna give you a equation omega square into K minus M omega square K into capital M plus twice M minus omega square capital M small m is equal to 0. Now let me copy this and let me go to a new slide. Okay, so here is the equation you're gonna have. So from here you can see this equation to be this right hand side to be equal to 0. Either this part must be equal to 0, or this part must be equal to 0, or this part must be equal to 0. Any one of these three must be equal to 0. Okay, or all the three must be equal to 0, or any one of them must be equal to 0. Then you will get on the right hand side, this part will become 0 whenever either this or this, any one of them is equal to 0, or all of them equal to 0. So that's why we will get omega square or K minus M omega square equal to 0, or K minus M omega square equal to 0, or this part here you can see, which is within the curl bracket, this part equal to 0. Okay, so from here we're gonna get three different solutions of omega square. So that's why let me write, this is omega 1, this is omega 2, and this is omega 3. This is omega 3, and if you solve this equation, so omega 1 square is equal to 0 means omega 1 is 0, and if you solve this from here, you're gonna get omega 2 is square gonna be equal to K by M. So omega 2, that's gonna be equal to root over K by M, and from the next part we're gonna have, omega 3 square is equal to K capital M plus twice M divided by capital M into small m. So omega 3, that's gonna be root over, it can be written this way, just give me a second, K by 1 by M plus 2 by capital M, we can write this way, right? Okay, and if you take 1 by M common, then here we're gonna have 1, here K by M, here it will be 2M by capital M, right? Hope you got it. So these are the three values we're gonna have. Okay, so these are the three frequencies we have got. So if the masses M1 and M2 M3 are in the ratio 1:2:1, that means we can consider m1 is equal to m, m2 is equal to twice m, and m3 is equal to again m. Therefore what we can write, omega 1 remains omega, then omega 2 that remains k by m, and omega 3 that will be capital K by small m 1 plus. Now this twice small m can be written as capital M because we have considered this 2m as capital M, right, by m. In that case this m cancel, then here we're gonna have 1, so m plus 1 2, so we end up getting this omega 3 is equal to 2 by root over 2k by m. So these are the three frequencies we will get, right? Now let me go to a new slide. First let me copy these three results. Okay, let me go to a new slide. Now you see, let me go back to previous slide. Here you see, let me copy this. Okay, just give me a second. Let me write this in the form of matrix. So let me write here. If you write this in the form of matrix, and now let me multiply a 1j, a1j, a2j, and a3j, okay, equal to 0. Okay, remember this. Now if we solve this, then multiply this one with this one, then what you're gonna have, you're gonna have this equation k minus omega. Now instead of writing omega, I'm gonna write here omega j. Okay, here we're gonna write omega j, and here also I'm gonna write omega j because it may be omega 1, omega 2, omega 3, right? That's why I'm writing here omega j square m into, so first coefficient is a1j, so I'm gonna write here a1j, then next term is minus k, so minus k into the next term of this column matrix a2j, then third one is 0, so 0 into this one, that's gonna be again 0, so we got equal to 0. Similarly we will get, if we multiply this one with this column, then we're gonna have minus k a 1j, then plus 2k minus omega j square capital M a2j then minus k a3j, and third row this column, then we're gonna have minus k a2j, because first element is 0 into this one, that will be 0, and this one into this one, that will be this minus k a2j, then plus this one with this, that's going to be k minus omega j square m into a3j. So these are the three equations. Now here you see, first we're going to solve it for omega is equal to 0, right? So that is first mode. Let me copy this omega 1 equal to 0. So here you see, this is omega 1 equal to 0, and let me write these three equations. Let me copy these three equations. Here you see, let me write here. Okay, so we are doing it for omega 1, right? So that's why here instead of omega j, I'm gonna write omega 1. Okay, so let me replace the j by omega 1. Okay, so j, wherever you see j, make it 1. Okay, because we are doing it for omega 1. So here a31 instead of 3j, it is 2 1. This is a21, and this is 1 1, a11, a11, right? So these three equations we have got, and if we solve these three equations, then you will get a11 equal to a21 equal to a31. Let me consider it, suppose alpha. Okay, and one more thing, here omega 1 is equal to 0, so here you see this part will be equal to 0, here this part will be equal to 0, so here we will get ka11 only, ka11. Similarly here also this part is 0, so we're gonna have 2ka. Here we're gonna get this equation in this way, in this form, right? So similarly here also this omega 1 is 0, so we end up getting this k into a31, right? Now here you see, if you divide all these equations by k, then here k cancels, here also k cancels, here also k cancels, yeah, we're gonna have 2, here also k cancels. So I have divided both sides of these three equations by k, so we have got these three equations. Okay, so if you solve these three equations, then you will get that all these three coefficients are equal for this first mode omega 1, right? Hope you got it. Now you see how to solve this. First you see, from this equation it is clearly a11 is equal to a21, right? This implies, and from this equation it implies a31 is equal to a21. So a21 is equal to a11 and a31 is equal to a21, so we can write these three are equal, right? Hope you have understood this. Okay, so now let's go to second mode. Okay, first mode is done. Now for omega 2 is equal to 0, sorry, for omega 2, what was the value of omega 2? This is omega root over k by m, sorry, root over k by m. This is the value of omega 2 that we have got. Now again, using the same procedure, if we just let me copy these three equations. Okay, so again you see, in these three equations, if we put the value of here, omega 2 is nothing but omega j here, so we can replace j by 2, and from this first term what we can do, k minus, instead of omega j we're going to write here k minus, instead of omega j is k root over k by m whole square. That's going to give you k by m into m, there is m, right? So minus a11, so here m gone, so k minus k is 0, so first term going to be equal to 0, and we end up getting this second term only, minus k a22 is equal to 0 because j is 2 here. So if it is 0, then we can write a22 is equal to 0, right? Similarly, from these two equations, if we put the value of omega 2, then we're gonna have this equations of this form. Let me show you. minus a1 2 after cancellation of k plus you see 2 minus m by small m a22, then minus a32 is equal to 0, and next last one will be a22 is equal to 0. Again that's gonna give you a22 equal to 0, right? Hope you have understood this. So if a22 is equal to 0, this part will be equal to 0. If that is the case, then from this equation we end up getting minus a12 is equal to a32. That's what we're gonna have. Okay, so now, or we can write a12 is equal to minus a32. So let me take this as beta. Say it is beta. So if it is beta, we can say that a32 is equal to minus beta, and a22 is equal to 0 here we have already got. So these are the values we have, right? So similarly we can take the third mode, that is omega 3, which is equal to, let me go back to the slide where we have written omega 3. This is omega 3, you can see this is omega 3. So here omega 3, again if we obtain the equations, if we use these equations again, right, from these equations we're gonna have 3 equations, and those are of this form: minus 2m by capital M a13, then a23 is equal to 0, then we're gonna have a13 minus k capital M by small m a23, right, then minus a33 is equal to 0, then we're gonna have minus a23 minus 2mk by m a33 equal to 0. These equations will be obtained. So k is gone here. If you solve this, you will get a13 is equal to a33, and let it be suppose gamma, and a23, that's gonna be equal to you're gonna have a23 is equal to minus 2m by capital M into gamma. That's what we're gonna have, right? Then we're gonna apply the normalization condition. Which is m a1j square plus a3j square, and this was m1, this was m2, and this was m3, right? So here this m2 is nothing but capital M, which is equal to twice small m we have taken. So here we have to take plus capital M into a. For this first one coefficient is a1j, for this one a2j, and for this one a3j. For these two we have written this, and mass of m1 and m3 is m, so m is taken common, right? And m a2j square is equal to 1. So now you see, if we use these 3 results here, you can see for the first mode, the omega is equal to 0. We have got a11, a21, a31 is equal to alpha. If we use this if we use this result in this normalization condition, for omega 1 is equal to 0. We have got this. If we use this, then we're gonna have alpha is equal to 1 by root over 2 small m plus capital M, right? And for omega 2, which was equal to k root over k by m, right? Omega 2 was root over k by m, and for that we have got these solutions, a2 to 0 and a3 to is minus beta. Let me copy this results and let me use here. So we have got these results, right? So if we use these results in this normalization condition, then we're gonna have beta is equal to 1 by root over 2m. Okay, you can check it by yourself. Okay, and similarly for mode 3, this one we have got this results. So if we use these results, a13, a33, a23, here you see for this mode 1, this equation will be m into a11, a31, here it will be a21, right? And for this 3, you see this one will be a12, this one will be a32, and this one will be a22, right? Hope you have understood this. And similarly for this third case, omega 3, you're gonna have here a13, here a33, here you're gonna have a23, right? So for mode 3, we're gonna put j equal to 3. For mode 2, we're gonna put j equal to 2. For mode 1, we're gonna put j equal to 1, right? So for omega 3, which is equal to this one, root over k by m into 1 plus 2 small m by capital M, and we have got these values. So if we put these values here in this one, then we're gonna have gamma is equal to 1 divided by root over 2m into 1 plus 2 small m by capital M. That's what we're gonna have, right? Hope you have understood this. Now let me copy these 3 values, alpha, beta, gamma, and let me go to next slide. So here you see we have got this results. Now from here what we can do, as we have got all the 3, alpha, beta and gamma, so we can write that a11 is equal to a21 is equal to a31 is equal to 1 by what was alpha. We have considered this one alpha is equal to, we have got this, that is root over 2 small m plus capital M. Similarly we're gonna have a12 is equal to minus a32, a12 is equal to beta, right? So beta we have got 1 by root 2m, and a32 here, minus a32 is beta, so it's gonna be minus beta, so that's gonna be minus 1 by root 2m, right? Hope you have understood this. And a22 is 0, a22 is 0 here. Then again we have got gamma is equal to this, and let me go back to the previous slide. So here you see these are the values of a13, 23 and a33. Let me copy this. So here you see we have got gamma is equal to 1 by root over twice m 1 plus 2 small m by capital M. That's what we have got, right? And here you see a23, here a2 3. In this case, what we have got, if we replace this gamma by the value of gamma 1 by root over 2 small m 1 plus 2m by capital M, then what we're gonna have here, you see, so it gonna give you just give me a second. So if you simplify this, here we're gonna have minus 2, then under root, you have to multiply this small m by capital M. When you put it inside the root, then it will be capital M square by small m square. So if you write here in the denominator, it will be m by small m, right, square square. So here, and if we multiply these terms, then it gonna give you here, after simplification, you're gonna have 2 capital M into 2 plus capital M by small m. That's what you're gonna have, right? Hope you have understood this. Let me copy these values. Okay, let me copy these coefficients and let me take a new slide. So let me write it properly. So here we have a12 is equal to 1 by root over 2m, and a22 is equal to 0, and a23, sorry, 32, not 23, yeah, a32 is equal to minus 1 by root 2m, and now just give me a second again. Next a13 and a33, these two we have got 1 by root over 2 small m into 1 plus 2 small m by capital M, right? And then we have a23, which is equal to minus 2 divided by root over 2 capital M into 2 plus capital M by small m. That's what we have got, right? Hope you have understood this. Okay, so let me write these values properly. Okay, now we're gonna find the normal coordinates. How to find that? In order to obtain the normal coordinates, you must remember this. The normal coordinates we're gonna write q1 is equal to m eta 1. First you need to write a11, then actually let me write here m1. Okay, then next m2 eta 2 a21, okay, a21, then plus m3 eta 3 a31. So in the next equation, it will be of this form. q2 next coordinate will be m1 eta 1 a okay, now in the next one a12, okay, then m2 eta 2, then a22, then m3 eta 3 a32, right? In the next one q3 m1 eta 1 a13 plus m2 eta 2 a33, sorry, not 3, 23, then m1 3 eta 3 a 3 3. Here you see, observe the pattern. When you write q1, then a 1 1, a 2 1, a 3 1. So general form is a ij. So if you take qi, then you have to write this one I. So j will be 1 2 3, right? That means for q1, in case of q1, the coefficients will be here a1 1, a1 2, a1 3, right? If you observe this, then for q2, here 1 2 2 2 3 2. That means for q2 a1 2, it will, second one number will be always 2, a2 2, okay, a3 2. That means value of j is now 2. Okay, so qj actually, right? And that means for qj, the coefficient should be aij. So here I should write I is equal to 1 2 3. Okay, I made a mistake here, I 1 2 3. Okay, hope you have understood this. So similarly, q3, the coefficient should be a 1 3 2 3 3 3. The second number, this second number is 3. If you are writing 3 here, this second number is it's supposed to be if you are writing q1, then coefficient should be a1 1, a2 1, a2 1, and here it's supposed to be 3 1, right? 3 1. Second number is the number here, you can see. If you are taking q1, then second number will be always 1. If you are taking q2, then second number will be always 2, right? That is the pattern. Hope you have understood this. Okay, so, and with this aij, here we're gonna have mass and eta. Okay, mj eta j, that is equal to qj, right? That is the general term to represent. Okay, hope you have understood this. So now we're gonna use those values you can see above here. So now you see, first let me take this equation only, first one. Let me clean this, the remaining two. Here m1 we have taken small m, eta 1, a11 is this is the a11. You can take this root over 2m plus capital M. You know, a11, a21, a31, all these three are equal, so we can take this this term common. Okay, all are equal to this one, so it can be taken common. So within bracket we're gonna have m1 eta 1, m2 eta 2, m3 eta 3, and the common term is this one, 1 by root over 2m plus capital M. So here small m1 and m2 both are equal to m, so we can write this m1 and m3. m1 and m3 both are equal to small m, and m2 is this one was taken as capital M, right? So this is what you're gonna have, okay, in the first one. So from the second equation, when you write q2, then m1 and eta 1. So qj, when you write qj, coefficient should be mi eta I, then aij, right? So so we need to take the sum. Okay, m1 then eta 1, m1 eta 1, then a, so here we are taking 2, so 1 2 q2, right? So 1 2, then next term will be m2 eta 2 a 2 2, then next term will be m3 eta 3 again a 3 2. Okay, this is first number is 1 here, 2 here, 3, but second number remains 2 as you are taking q2 here. That's it, right? Hope you have understood this. So if we put this m1 is equal to small m, m2 is equal to capital M, and m3 is equal to small m only, then if we put the value of a1 to a22, a22 is 0 here, you see this is a22, so this term is not required here, so a22 is 0. Okay, and a32 is minus this, so we can write here this way, m eta 1 into 1 by root over 2m minus m eta 3 1 by root over 2m. This minus is because of minus is here because of a32 is minus 1 by root over 2m. Hope you have understood this. And if you take this part common, m into 1 by root over twice m, if you take that common, and what you're gonna have, then you're gonna have m into 1 by root over 2m eta 1 minus eta 3, right? That's what you're gonna have. And you see, you can write this way, if you write the m inside the square root, then it will be m square by twice m cancels m, so we end up getting this root over m by 2 into this is q2, right? This is q2. So similarly you can obtain q3. If you obtain q3, and q3 again we're gonna have m1 eta 1 a, now 1 3, then m2 eta 2 a 2 3, then again m3 eta 3 a3 3, right? So a3 3 a1 3, then a2 3, using those values here we're gonna end up getting q3 is equal to, that will be equal to of this form. After simplification we will get root over small m capital M divided by 2 into 2 small m capital M within bracket eta 1 plus eta 3 minus 2 eta 2. That's what we will get, right? Hope you have understood this. So here you see, so here we have to use these results, okay, in this equation, then we will get that, right? So now let me write all the values of q1 q2 q3. q1 we had got this. Let me copy the value of q1. Okay, so here is q1, this is supposed to be eta 3. Okay, similarly let me write q2. We had got this here, you see, let me copy q2. So here is q2, and we know that m1 equal to m, m2 is equal to twice m, and m3 is equal to, m2 means capital M, which is equal to twice m, equal to m3 is also equal to m. So if we put those values here, you see here we're gonna have root over, if you put this capital M, if we replace this capital M by twice small m, then we're gonna have here 4m, and within bracket we're gonna have m eta 1 plus 2m eta 2, right? Let me simplify this. plus m eta 3. So this information is given in this question because this should be in the ratio 1:2:1, right? Sorry. So because this m1 is as m1 is to m2 is to m3, the ratio is 1:2:1. So we have considered the masses as m twice m and m. So then the ratio will be 1:2:1, right? So we have used those values here, m twice m, then again m, right? So if we do that here, this capital M is replaced by twice m, then twice m plus twice m, that's gonna be 4m. So that is what I have written here. Okay, so here I have written 4m. Then you can take this m as common, right? Then we're gonna end up getting within bracket this, right? So m is taken common now. So this is what we're gonna have, right? So now you see, so when you write the square over this whole term, then this m will be m square, then m cancels m square to give m. So we end up getting m is equal to 4:2 by eta 1 plus 2 eta 2 plus 3 only eta 3. Then similarly here you see, here it is m remains m here, nothing to be changed here. So in the next term here, if you replace this capital M by twice m, then what we're gonna have? If you replace the capital M by twice m, then let me copy this last step and let me take a new slide. So here you see, if we replace the capital M by twice m, m into twice m by 2 into twice m plus capital M is replaced by again twice m. Okay, then what we're gonna have here, you see, just give me a second, and here eta 1 plus eta 3 minus 2 eta 2. So here, so 2m square divided by 2 into 4m, so m cancels m square and 2 gone. So we end up getting root over m by 2 eta 1 plus eta 3 minus 2 eta 2. So these are the normal coordinates, q3, q2, and this is q1, right? So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.